Welcome everybody. So today we are in our fifth class for module 2. So today in our class we are going to see the conditions of equilibrium of a floating and submerged bodies. So for determining the conditions of equilibrium of a floating and submerged bodies, we need to understand what is center of gravity, what is center of buoyancy, and what is what is metacenter. That is, we represent it by M. So these three concepts we have already studied in our previous classes in the first four parts. Okay, center of gravity is the point where the whole area of the body acts, or whole weight of the body acts. Center of buoyancy, and this center of gravity act downwards. The force, the weight of the body acts downwards. So the force of center of gravity acts downwards. Now, center of buoyancy, it is the upward force when a body is immersed in water. And so this upward force acts upwards. Now, the metacenter, when a floating body is tilted to some angle, it will change its center of buoyancy from B to B1. So, you will have a neutral axis, and this buoyant force will meet in the neutral axis at some point, and that point is called metacenter. Okay, now with this understanding, we will see what are the conditions of equilibrium. So we have two conditions. See, equilibrium conditions are three. That is a stable equilibrium, unstable equilibrium, and neutral equilibrium. Okay, we have stable, unstable, and neutral. And for these cases, for stable, unstable, and neutral equilibrium, we are going to see these equilibrium conditions for a fully submerged body and for a submerged body. Fully submerged body and for a partially submerged body. So partially submerged body will be a floating body. Now, a submerged or a floating body is said to be unstable if it comes back to its original position after a slight disturbance. So what is the condition if it needs to come back to its original position? The relative position of the center of gravity and center of buoyancy of a body determines the stability of the submerged body. Okay, so this metacenter, it depends on the center of buoyancy. Metacenter occurs when this center of buoyancy changes its position when the body is tilted. So, the relative position, if you know G, B, and when B is adjusted, or when B is changed, M also, metacenter also, then you can say whether the body is in stable equilibrium or unstable equilibrium or in neutral equilibrium. Okay, now we will go one by one. So totally two conditions. Okay, this is our case 1. This is our case 1. Case 1 is conditions of equilibrium of a completely submerged body. Okay, so it is completely submerged body. So you can see in the diagram now. So you can see this is the free surface of water. Free water surface. Okay, free water surface. So you have water. This is a water body. Okay, so this is our water body and this is the free water surface. So we have an object or a body immersed inside this water body. Okay, this is our body immersed inside the water body. And see, this portion that is marked in this green color indicates that this body has weight on the lower portion. That is, this portion has more weight than the other portions. Okay, just the reason is in order to show the difference between the center of gravity and center of buoyancy. See, now you can assume that this object is uh, filled with some material to this portions, in the down portions, in the bottom portion, so that the bottom portion is heavy and the top portion is lighter. So that means our center of gravity for this conditions, for this case, our center of gravity may lie here. We represent our center of gravity as G, and the weight of the body acts along the, this is the line of action of the weight of the body, and this weight of the body acts through the center of gravity, and the weight of the body we will represent it as W. Now the center of buoyancy will lie somewhere here. Okay, we will call it as the center of buoyancy, that is the upward force acting on this body in order to keep the body in equilibrium. So this buoyant force acts upwards, so we take that force as FB. Okay, so G is the center of gravity, B is the center of buoyancy, the weight of the body acting downwards, and the buoyant force acting upwards. Now we are tilting the body. We will try to tilt the body. So this is our normal axis. Our normal axis of the body lies like this. So what happens is when you are tilting, this is your G, center of gravity. Your weight of the body act perfectly downwards, and here lies our center of buoyancy, and center of buoyancy acts upwards. And you are tilting it in clockwise direction. So when you tilt in clockwise direction, when this buoyancy is in top of G, this buoyant force will act in the anti-clockwise direction. Okay, buoyant force will act in the anti-clockwise direction to keep the body in equilibrium. So this is the condition for stable equilibrium, right? When a body is fully immersed inside the water, the condition for stable equilibrium. So now what are the conditions of stable equilibrium is, first condition is when the weight of the body is equal to the buoyant force if the center of buoyancy B is above G, then we say the body is in stable equilibrium. So this is the condition for a fully submerged body to be in stable equilibrium, that is B is above G. Center of buoyancy is above the center of gravity. Okay, so that means the second case is when the body is tilted in clockwise direction, the buoyant force acts in anti-clockwise direction. In order to keep the body in equilibrium. Okay, now we will move on to our second condition, that is unstable equilibrium. Okay, so this is the condition for unstable equilibrium. So now we are assuming a body fully submerged inside the fluid, and the top portion of the body has some weight. So the weight is accumulated in the top portion of the body. So if that is the case, our center of gravity will lie on the upper half. So this is our center of gravity, and our center of buoyancy will lie below G. So the weight acts downwards and the buoyant force acts upwards. And when the body is tilted in some clockwise direction, this is our neutral axis, and this is our G, W acts downwards, and the B, that is center of buoyancy, also lies on the neutral axis, and force of buoyancy acts upwards. Now what happens is the weight, that is the downward force, will be equal to upward force. The weight of the body will be equal to the buoyant force. But the center of buoyancy will lie below the center of gravity. So the body is in unstable equilibrium. The body will be in unstable equilibrium. The reason is this buoyant force also will act in the clockwise direction. Okay, so when a slight displacement is given to the body in the clockwise direction, it creates a couple, it makes a couple due to this W and FB. That's why this FB also acts in the clockwise direction. Thus, the body do not return to its original position and hence the body is in unstable equilibrium. So what are the conditions? See, here we will write, in the first case we will write one more condition, that is the body will come back to its original position. The body comes back to its original position. So here in the second case, for the unstable equilibrium, so the first condition is the weight of the body will be equal to the force of buoyancy, and this gravity, that is G, is above B. That is center of gravity is above the center of buoyancy. Center of gravity is above the center of buoyancy. Okay, the reason is the top portion is heavier. The top of the body is heavier. So G is above B. The second condition is when the body is tilted in clockwise direction, FB, the force of buoyancy, also acts in the clockwise direction. So which results in unstable equilibrium. This results in unstable equilibrium. So the third condition is the body do not come back to its original position. Do not come back to its original position. Now the third condition is neutral equilibrium. So okay, this is neutral equilibrium. This is the condition for neutral equilibrium. So for neutral equilibrium, both the center of gravity and center of buoyancy coincides, will lie at the same point. So there is no disturbances given. So there is no need of clockwise and anti-clockwise movement, anti-clockwise directions or change in directions. So this is the condition for neutral equilibrium, that is W is equal to FB, and the second condition is G and B, that is center of gravity and center of buoyancy, lies at same point. So these are the conditions of neutral equilibrium. Okay. So now we will move on to our second case. So second case is conditions of equilibrium or stability of a partially submerged floating body. See, what we have seen, the previous case was fully submerged. Now it is partially submerged. This is our case 2. So when it is partially submerged, okay, we will draw the free surface of the water. So this is our water body. Okay. Now, see, for a partially submerged or a floating body, the relationship is between G and M. That is the center of gravity and metacenter. Okay. Previous case it was between G and B, center of gravity and center of buoyancy. Now it is the relationship is between center of gravity and meta center. So we will move on for the first case, that is for the stable equilibrium. Okay, this is first case. We will go for stable equilibrium. So what happens is, for a stable equilibrium, when the point M, that is when the metacentric height, metacenter M is above G, the floating body will be in stable equilibrium. So the first condition is M is above G. Metacenter is above the center of gravity. Now, if a slight displacement is given to the floating body in the clockwise direction, when you give a slight displacement in the clockwise direction, the center of buoyancy shifts from B to B1. So we have our center of gravity here, center of buoyancy here, and this center of buoyancy gets shifted to B1. Okay. So this is our neutral axis. So this B gets shifted to B1 such that the vertical line through B1, it cuts at M. So here lies our center of gravity, and the vertical line through B1, that is our FB, cuts at M. Okay. So here the weight acts downwards and force of buoyancy acts upwards. So this means our M lies above G. So here weight is acting downwards. So then the buoyant force FB through B1 and weight W through G, it constitute a couple acting in the anti-clockwise direction and thus bringing the floating body to the equilibrium condition. So the second condition is, when we are applying a clockwise, when the body is tilted clockwise, so body tilted clockwise, it results in, that is, force of buoyancy acts in the anti-clockwise direction. And the third condition is, the body comes back to its original position. Comes back to its original position after a slight tilt. Okay. So now the second case is unstable equilibrium. So this is unstable equilibrium. So here what happens is, for unstable equilibrium, the point M lies below G. So we will have G, B, and M will be lying somewhere between G and B, or that in other words it lies below G. So this becomes our neutral axis. So our G lies here, this B gets shifted to B1, and the force of buoyancy, when you draw the line, this will meet the normal axis at a point below G. So this is the condition for unstable equilibrium. Okay. So the weight acts downwards, force of buoyancy acts upwards. Here also the weight acts downwards. So for unstable equilibrium, the first condition is, our M lies below the center of gravity. Metacentric height is below the center of gravity, and when the body is given a clockwise, is tilted in the clockwise direction, the force of buoyancy also will act in the acts in the clockwise direction, which will make the body unstable. Okay, this will result in unstable. The body do not come back to its original position. Now, the third case is This is the neutral equilibrium. So for neutral equilibrium, our G and M will lie at the same point. Okay, so for neutral equilibrium, M and G lie at same point. So this is called a neutral equilibrium, and these conditions are very important for your exam point of view. Okay, the conditions of equilibrium of a fully submerged and a partially submerged or a floating body. So we will just see the diagram once again. See, for a fully submerged body, if our center of buoyancy is above G, it is a stable equilibrium. If the center of buoyancy is below G, it is unstable equilibrium. For neutral equilibrium, G and B, center of gravity and center of buoyancy, lies at the same point. When the body is partially immersed in the water, okay, when our center of gravity lies below metacenter, then that is a stable equilibrium. If the metacenter is below center of gravity, it will be an unstable equilibrium. And if the metacenter and the center of gravity are at the same point, then that is neutral equilibrium. Now we will solve just one problem, because we have already solved 5 problems, many problems for determination of metacenter. This is just for some more better understanding. We will do one more problem, just one problem. Okay, simple problem. So the problem is, a solid cylinder of diameter 4 meter has a height of 4 meter. So diameter is 4 meter, height is also 4 meter. Find the metacentric height of the cylinder if the specific gravity of the material of the cylinder is 0.6 and it is floating in water with its axis vertical. State whether the equilibrium is stable or unstable. So, see, the cylindrical body is floating in water. So, we will draw the cylindrical body, right? So, this is okay. So, this cylindrical body is 4 meter height and it is floating in water. Okay. So, this is a cylindrical of diameter 4 meter. So, the cross section is of a diameter. So, this cross section we have 4 meter. The diameter of the cylinder is 4 meter. So, one more condition is given, that is the specific gravity of the material of the cylinder is 0.6. So, now the other things, only these things are given, right? The diameter is 4 meter, height is 4 meter and the specific gravity is 0.6. We need to find. So, the specific gravity S is 0.6. Only these 3 details are given. We need to find the metacentric height. So, how will we determine the metacentric height? See, we know weight of the cylinder will be equal to weight of the water displaced. So, weight of the cylinder, we know it is a density of the cylinder, gravity into volume of the cylinder, that is equal to weight of the water displaced is density of water into gravity into volume of water displaced. So, we know density of the cylinder is equal to specific gravity into density of water. So, the specific gravity is 0.6 into density of water. So, this G and G gets cancelled. Now, volume of cylinder is equal to pi r square h, right? Pi into r square into, that is height of the cylinder, right? Height of the cylinder is 4. So, that is equal to density of water into volume of water displaced. See, volume of water displaced means this volume. This is the volume of the water displaced. So that is equal to, again it is a cylinder, cylindrical shape. So pi r square into height, you will take the height as h, height of the water displaced. So we will take this height as h. So we can cancel this density of water, pi r square and r square. So what we get is h is equal to 0.6 into 4. So we get this height, 0.6 into 4 is 2.4 meter. So this height, that is the height of the cylinder immersed in the water is 2.4 meter. Now our center of gravity, we will mark the center of gravity. So the center of gravity will be 2 meter from the bottom, right? Because 4 by 2, it is 2 meter from the bottom. And the center of buoyancy B, center of buoyancy will be h by 2. So 2.4, this distance by 2. So 2 by 4 by 2, it is 1 point, this distance is 1.2 meter. Okay, so now we know the metacentric height is gm. So gm is equal to moment of inertia by volume of the cylinder immersed inside the water minus bg. So gm is equal to, this is a cylinder, so the top face is a circular. So we know the moment of inertia for a circular section is pi d power 4 by 64 divided by the volume immersed inside the water, that is pi r square into h is 2.4 minus bg. So bg is 2 minus 1.2. So bg, the distance is 0.8. You substitute, we get gm is equal to minus 0.3833 meter. So already we have seen the previous problems while determining the metacenter. Your gm may be positive or negative. So positive means our metacenter lies above the center of gravity. Negative means our metacenter lies below the center of gravity. If the metacenter lies below the center of gravity, then the cylinder is in unstable equilibrium. Okay, negative sign. So negative sign indicates m is below g. The metacentric height is below the center of gravity, which results the cylinder is in unstable equilibrium. Cylinder will be in unstable equilibrium. Okay, so if you are asked in the question to find whether it is in stable or unstable equilibrium, just find m. Okay, just find m. Find gm. If this gm is positive, then it is in stable equilibrium. If it is negative, unstable equilibrium. And if it is in 0, then it will be in neutral equilibrium. So thank you for today. Thank you.